This is Mr. Smith from Advanced Math Tutors, and today we're talking about the first derivative test and U. So, real quick, let's talk about what the first derivative test says, and then we'll do a couple examples. So, get out of here. Pretty basic. It says if f prime of x changes sign from positive to negative at a critical point, x equals c, then there's a local max. If f prime changes sign from negative to positive at x equals c, that's local min. And if f prime does not change sign, then there are no local extrema there. So, and this only applies if the function is continuous at a critical point. So it's pretty basic. It says if f prime changes from positive to negative, meaning if f prime is positive, the function is increasing. So it's got to be going up like this. If it changes from going up to going down, then there must be, at the point where it changes right there, a maximum, okay? And I'm drawing this horizontal line here, even though he's super sloppy. Get out of here. There you go. Kablow. Well, pretend that touches there. That's a horizontal tangent, and that's how you would find the critical point. Remember, critical points are where the derivative is undefined or zero. So you could also have something like this, where there'd be a corner there. The derivative will be undefined at that point. It changes from positive to negative. That's a maximum. If it changes from decreasing to increasing, then the derivative is changing from negative to positive, and that creates a minimum, whether it's a nice smooth curve with a horizontal tangent or if there's a corner there. And the last one says that if the derivative doesn't change sign, even though there's a critical number, so it could be something like this. So you can see it's horizontal here, but the function is increasing on the left side and increasing on the right side. So the derivative is positive over here in this section, then it's zero at this point, and then it's positive again. Well, since it didn't change sign, then there's no max or min there at all. Okay. Let's look at a couple examples. That's going to make it a lot more obvious for us here. So let's try a happy function. In blue, why not? Let's try y is equal to x to the 2/3 times x plus 2. Why not? Okay. Well, if we want to, the question will be, here's a function, find all relative extrema. There you go. So what we need to do is find the relative extrema. We know they can only happen at critical points, so we find all the critical points. Then we use the first derivative test to determine if they are maximums or minimums or neither. So step one, derive this thing. dy dx using the product rule is 2/3 x to the negative 1/3 times x plus 2 plus x to the 2/3. There we go. Now our goal here is to find out where's this thing zero or undefined. But before we can do that, it makes sense just to kind of simplify this thing down and get it to be one nice big fraction. So just to rewrite this, we're going to have 2 times x plus 2 over 3x to the 1/3 plus x to the 2/3. Simple enough. Now we want to get this all together here. That's the easiest way to find out where something equals zero. If it's one big fraction, then we can factor the top and the bottom separately. So what we're going to do is get a common denominator. So before we put these here, I guess, we're going to multiply x to the 2/3 over 1 by 3x to the 1/3 over 3x to the 1/3. And that's going to give us our common denominator. So we're going to end up with here 2x plus 4 plus 3x to the 3/3, because x to the 2/3 times 3x to the 1/3 is 3x to the 3/3, which is just x to the first, over 3x to the 1/3 when you put all that stuff together. Alright, so now to resolve this here for a second, we want to generally work with the simplified version of our derivative. So y prime dy dx, same thing, is 2x plus 3x is 5x plus 4 over 3x to the 1/3. Now we want to know where that is zero and undefined. So it equals 0 when the top is 0, and that happens at negative 4/5 if you solve that. And it's undefined when x is 0, because that's when the bottom would be 0. So generally speaking here, when you have a fraction, it equals 0 when the top is 0, and it's undefined when the bottom is 0. So when you're looking for critical numbers, that's what you're really looking for. Where's the numerator 0? Where's the denominator 0? So there we go. So these are our critical numbers. We found this before when we were doing the extreme value theorem things. What we want now is to determine, well, are there maximums or minimums at those points? And how we do that is we just got to find out what the derivative is doing. It's changing sign, hopefully, and we want to know if it's going from positive to negative or negative to positive. And the way we do that is the way we've been finding out sign all year is by making a nice little number line. So we've got negative 4/5 and 0. So the derivative is 0 at negative 4/5, undefined at 0. So therefore it must be positive or negative at all these other points. Oh no, period's over. So what we're going to do here is plug in points to determine if this fraction here, the derivative, is positive or negative. Okay? So we'll plug in like negative 10, that's back here. Negative 10 makes the top negative and the denominator negative. Negative divided by negative is a positive. You plug in something between 0 and negative 4/5, like negative 1/5. Well, that's going to make the top positive and the bottom negative. A positive divided by negative is a negative. And when you plug in a positive number, like 8, you get a positive number divided by a positive number, which is a positive number. So what we have going on here now is that we have a relative maximum when x is negative 4/5. And we'll find the y value by plugging negative 4/5 back into our original function. Now, this isn't going to be a super nice number, but that's okay. The y value is negative 4/5 to the 2/3 times negative 4/5 plus 2, which is 6/5. That's the y value there. Kind of ugly, but that's just the way it is. If you had a calculator, you can turn that into a decimal or something. Doesn't matter. And there's going to be a relative minimum at x equals 0. And when you plug 0 back into the y, again, testing for the y value, when you plug it into this function here, we get 0 times 2, which is 0. There we go. If for some reason we plug back in our x value into our function and got something undefined, well then there's not a max or a min there at all. There's like an asymptote or a hole or something weird's going on. So then there's not a point there. If there's no point, it can't be a max or a min. But in this case, they both were points, and the first derivative test says if derivative goes from positive to negative, there's a max. If it goes from negative to positive, there's a min.